Hello everyone, my name is Prakruti P. I'm a second year computer science engineering student studying in Sri Venkateshwara College of Engineering, and today I'm here to give a presentation on the topic developing a C program to stimulate scan disk scheduling algorithm in the subject operating system. So today I'll be discussing about the main topic, which is what is ScanDisk scheduling algorithm, its advantages and disadvantages, and I'll be giving an algorithm for the ScanDisk scheduling, and then I'll be discussing an example and as well as a program, and then I'll be concluding this presentation. So what is a ScanDisk scheduling algorithm? A scan is a disk scheduling algorithm that serves requests generated by the memory management unit. So it can be also called as elevator algorithm. In this algorithm, we can read and write the head, which has to move from in one direction and fulfill all the requests until we move to the end of the disk. So this is known as the scan disk scheduling algorithm. And also in a scan disk scheduling algorithm, the head starts moving from one end of the disk and moves towards the other end, servicing the request in between one another and then reaching the other end. Then the direction of the head is reversed and the process continues as the head continuously scans back and forth to access the disk. So this algorithm works as an elevator and is also known as an elevator algorithm. So as a result, when the requests are made at mid-range, these are more serviced, and then these arrive behind the disk arm, which will have to wait. Some of the advantages of ScanDisk algorithm is that the algorithm is very simple and easy to understand, and the scan algorithm has no starvation, and this algorithm is better than the FCFS disk scheduling algorithms. And some of the disadvantages of ScanDisk algorithm is it is more complex algorithm to implement, and this algorithm cannot be fair because it causes a long waiting time for the cylinder just visited by the head. This also causes the head to move to the end of the disk in such a way that the request arriving from ahead of the arm position would have to immediately give a service, but some other requests are also arriving behind at the same time, where the arm position will have to wait for the request to complete. These are some of the disadvantages of the ScanDisk algorithm. Now I'll be giving an algorithm for the ScanDisk. So in the first step, we will make there are basically 8 steps, and in the first step we'll make a request array which represents the request array which represents an array storing index of tracks that have been requested in ascending order of that time we arrived, which means that the request array represents an array which stores indexes of tracks which have been requested in an ascending order in the time of arrival, and then the head is the position of the disk head. So here the head is the position of the disk head. In step 2, we'll see that the direction represents whether the head is moving towards the left or towards the right. And in step 3, in the direction in which the head is moving, so all the service tracks is done one by one. And in the fourth step, we calculate the amount of distance the track has traveled from the head, and in the fifth step, there is an increment of total C count with this distance. And in the sixth step, there is a currently serviced track position now, which becomes a new head position. And in the seventh step, we go to the step 3 again until we reach the one of the ends of the disk. And in step 8, which is the final step, we have, as we reach the end of the disk reverse, then we reverse the direction and go to the step 2, where again until all the tracks in the request array have not been serviced. So this goes on happening until all the request array have been not serviced. And here's an example. As we can see in the slide, there's an input which is a request sequence which consists of a number of sets, which is the first set number is 176, and then it's 79, 34, 60, 92, 11, 41, and 114. These are all different numbers which are which include the lesser and as well as greater numbers. So there's an initial head position here is 50, and then the direction is left because we are moving from right to left. And the output of the given above example is in the next slide, which is the total number of seek operations is 226, where the seek sequence is from 41, 34, 11, 0, 60, 79, 92, and 114 and 176. So the following chart we can see in the slide shows the sequence in which all the request tracks are serviced using a scan. Here the scan disk scheduling algorithm graph is given. As you can see, it first starts from 50, then it goes to 41, then it goes to 34, and then it goes to 11 and then 0. Again from there it moves towards 60, then it moves to a 79, 92, 114, then it finally reaches 176, as we can see in the graph. So therefore these total seek count can be calculated by the following, as we can see in the slide. So first we'll subtract 50 from 41, then add it with 41. We'll subtract all the numbers like 50 minus 41, 41 minus 34, 34 minus 11, 11 minus 0. As we saw here in the output, we subtract accordingly. So we subtract again 60 from 0, 79 from we subtract 79 from 60 from 79, and then we subtract 92 minus 79, 114 minus 92, then 176 minus 114. Then we add all the results, and then we finally get the value, which is 226. And here we can see a program which is related to disk scheduling algorithm. So as we can see, so here as we'll start a program with hashtag include stdio.h, and then there's a void main, which is the main part of the program, and then we have integer values, which is 20. We take some values. As we can see, there's an array, there's a temporary, there's a k, total, p, h, I, j, n. These are all the variables which we are taking, and then in the second line we can see sum is equals to, in the next line we can see sum is equals to 0, and then we can see there's printf, then enter the number of tracks that has to be traversed, and then we enter the position of the head, and then there's enter the tracks, and then we use for loop, and then as the scanning is done, and then again we use the for loop. So this is a program which represents the disk scheduling algorithm, how it is done. So this is a code for disk scheduling algorithm program. So now I would like to conclude by saying that a scan disk scheduling, it basically starts from one end, then services all the requests along the way, and then it reverses the direction. And the scan disk scheduling adds a predictability by ignoring the request while reducing the variability in waiting times. And these algorithms are very efficient and ensures all the requests are eventually served. So this is the main help, and this is why scan disk algorithm is very useful. And I would like to conclude and I'm really thankful for you guys for watching my video. See you guys in the next.